Okay, so in lesson 12, it's called Sprite Movement. The main idea is we're learning how to use the counter to make the sprites move. And there's not a code that just says, or nothing that we know of that says, count by one. So 1, 2, 3, 4, 5, 6, 7, 8. We have to add a number to the variable to make the movement. So I'm looking at 8a, which is the practice for lesson 12. We have the pan, and if we draw the pan, it's stagnant. We're asked to use the counter pattern with the sprite's rotation property to make it spin. So we're going to, again, use the rotation property. I'm going to put it here, right between the background and the draw sprites. This is going to be the pan that's rotating. And to do this, we are going to just use pan.rotation plus, let's just say plus 1. So it's going to rotate 1 degree every frame. And if we do that, it looks pretty good. If we want to change the numbers and make it slower or faster, we can. That part isn't a big deal. I think we're really focused on making sure we know how to use the counter. So essentially what's happening is the pan's rotation is moving by 5 degrees each time. Okay, so every frame it moves 5 degrees or rotates 5 degrees. We're going to go ahead and look at B next. B, it looks like the car is going backwards. Oops, I'm going to go and reset this. B, it's not that it's going backwards, sorry, it's going off the frame, off the scene. And we kind of notice on the bottom left every time I reset and run it. Okay, and it's hard to see what's going on. Okay, so the program is supposed to have it move from the bottom left to the top right, like here. However, the motorcycle moves off the screen too quickly to see what's going on. So to see what's going on, they're suggesting we use the watchers so we could look carefully at what the code is doing. So we have, let's run it and look at cycle.x. Okay, when I run it, we notice that the x is going to the right. So the x is increasing, and obviously it goes off the screen. After 400, it's off the screen. We're going to add a watcher for cycle.y, so I could just copy and paste this if I want, or just simply type it. Cycle.y, hit the plus sign and add it. And if I kind of reset again, we kind of see what's happening with the y, and it looks like it's increasing really quickly. And remember, this is one of the hard parts to remember. When it increases, it's actually going down when we do coding, so it's a little different from math. So when it's increasing, the y value is increasing, it is going down. Okay, so if we wanted to go up, we have to have the number decrease. So let's go ahead and fix this now. Again, the programs shows that the motorcycle disappears because it's going down off the screen. We want to go upwards, so we want the y value to decrease. There's a couple things we could do. We could add a negative, or we could subtract. Let's go ahead and just use subtraction just to keep things consistent. Cycle.y minus, let's go ahead and just put 10 degrees because they're going up to the right 10 degrees. I'm sorry, 10 units. And it looks like it's working pretty well. Okay, so the car is going upwards because we are reducing the y each time. If we want to go slower, we just use slower values. So maybe instead of moving at 10 each time, let's move 5. And again, we notice it goes upwards. Alright, finally the rotation. So here we have, if we run the program, we have stagnant gears. They're not moving. However, we want them to actually rotate. Notice that the red rotates clockwise, the blue counterclockwise, and then the red clockwise. So we're going to go ahead and make the gears rotate so they look like they're working in one system and in sync with each other. So what we're going to do is, of course, we're going to use the rotation block. Okay, let's go ahead and start with the red gear just because it's on top. I want it to go clockwise. So we're going to look for the variable name, and they call it red gear. And what's happening to red gear dot rotation, and again, you can use the block and drag it. I like to just type it out. It's up to you. Red gear dot rotation is that in the rotation is going clockwise, so that's a positive. So I'm going to go ahead and let's just say +1 for now. Alright, if I kind of run it, and we notice it goes the correct way. Okay, well, let's see what happens if I do the same thing with blue. I'm going to copy everything over for the blue gear, which is this one, this middle one. And if I do blue gear dot rotation and I do +1, let's take a look to see what happens. When I do that, again, we notice that the blue gear is going clockwise. We want it to go counterclockwise. We want it to go the other way. Okay, so again, we're thinking kind of positive and negatives if we want to do the opposite. So I could just say +1 or +(-1). I'm going to go ahead and reset and run it, and it looks like the red's going the correct direction, blue's going counterclockwise, so that's negative. Okay, we want the green to go which way? We want it to go clockwise. So do I want to use a positive or negative? If I want to go clockwise, I'm going to use a positive. So for the final gear, the green one, I'm going to name this green gear dot rotation. We're going to do green gear dot rotation. Because it's going clockwise, I'm going to add 1. I'm going to reset and run, and it looks like all the gears are running in unison. And keep in mind, the numbers, the values have to be same how they're rotating. If I'm rotating by, let's say, 2 on one of them, it's going to kind of look out of sync. You're going to notice how it kind of overlaps. Maybe we can use a bigger number to kind of emphasize that. Okay, so we want to make sure that they're rotating at the same magnitude, the same value. Okay, so that is the practice problems for lesson 12.